To set the stage, I am delighted to give the floor to Alper Akdag, Chair of the A.SPIRE Working Group on Energy and CO₂. A.SPIRE is the European association representing energy and resource-intensive process industries through the Process for Planet Partnership, and plays a key role in driving innovation for climate-neutral and circular industry. Alper, the floor is yours.
Thank you so much, Angela. A very welcome also from my side, and good morning to everyone. As Angela just mentioned, I'm representing the A.SPIRE Energy and CO₂ working group, but I'm also working in a company called ABB, which is the engineering equipment manufacturer for the process industries and for these activities, which we are really active in these industries. If we go to maybe as an introduction to my presentation, if we go to the next slide, maybe. The topic is why industrial electrification now. I think with this first slide, I want to give a kind of background. What is the involvement of the electrification in today's industries? And if we go to the next slide, this shows a kind of very nice view. What is the percentage of the electrification or the total energy demand in the industry?
Sorry, I don't see the slides. 1 minute.
I can see it.
Okay. Sorry. Okay, thank you.
Angela, I think it's a kind of unique issue, but if there's anyone, we can. Anyway, this it's total energy demand in the industry. It's just shown on the left-hand side. And for this portion, almost half of it, around 40–45% or even higher, is going to the process heating. For instance, whatever we use in the industry as an energy demand is half of it is going to the heat, and that's why it's very, very important for us just to concentrate on this activity. If we want to go to the sovereignty in Europe, and also seeing what is our dependence on the outside. And if we zoom in on this portion, this half of the portion process heating, you can see the split of where is the source of this heating is coming, mainly fossil fuels, and very, very small portion of it. You can see in this diagram on the right-hand side is the very small portion is coming from the electricity, and the dependence of the process heating is really heavily depending on the fossil fuels. And you can see on the right side of the slide, which is a kind of statistic from Eurostat, showing that how is the development of the fossil fuel imports to the Europe either from the oil or natural gas or liquefied or gases, natural gases. And we are talking about not the billions, we are talking about the trillions in total per year. If €500 billion is spent just for this extra EU imports in order to energize our industries. And this is why we are really focusing on our activities, the process heating in industry, which is the half of the energy demand, and what's the portion of the electricity in this industrial heating. If we go to the next slide, maybe after this introduction, seeing where this heat is used. Of course, heat is not it's single meaning this one temperature. It depends on the different industries. For example, if we go to the iron and steel, the biggest portion of the required heat is for degrees more than 500, even bigger than 1000 centigrade degrees. And it is the biggest portion for the iron and steel industries. And it depends for different industries, different use of temperatures, but iron and steel, as well as the chemicals, requires very high temperatures, about 500 degrees, even above the 1000 degrees. And that's why it's very important that we can manage this this heating with some source of energy sources that we can sustainably obtain. But this is also one portion of the heat demand, but there are also other industries like food and beverages and other that requires not so high heat, but also lower than like 100 degrees to 200 degrees. And it depends on the demand on the industries. And this is very important because the technology that is required to reach these heats are different for, and there are some technologies that's like the heat pumps nowadays is very, very important. And it goes to 200 degrees, even there are some technology development to 150 degrees, but this is the limit that we can reach with the heat pump. Then we have to find out more different technologies that goes above this higher temperatures. And as you can see on the pie chart, 50% of the heat demand is above 500 degrees, which requires really special technologies like the plasma torches or arc furnaces or other technologies that we can reach up to such high temperatures to allow our processes are working properly. If we go to the next slide, then you can see that Europe that's highly depending on the fossil fuels, and this is how the industrial heat electrification gone. But then the question comes, why the electricity is not so good enough just to make the all industry for electrified heating? And this is the answer. It shows the percent or the ratio of the electricity to the gas prices. It is different for different countries, but if you see that Germany, Belgium, Italy, it's high on the top chart, showing that the electricity is 3 times or even 3.5 times more expensive than the gas pricing. It explains very easily that the electricity is still very expensive to convert all industry to electrification. And there are some countries are lower than the gas prices. It depends on their electricity generation topics. But this is how there is a big issue that we can go easily with the electrification in the industry. If we go to the next slide, maybe. And this is the challenges that we are facing in the energy intensive industries. The prices are very high. And when we compare to US and China, and this definitely it impacts our production cost and product cost, just if we depend on these prices. And the investment capex, capital investments, are also very important because you have to change the factory installations, and it creates a kind of significant upfront investments and for these industrial assets. And with the increased cost of either in the capex or in the OPEX, in the operational electricity prices, there's a risk of carbon leakage, which this high cost may drive the production relocations to other cheaper production locations in China or in other places. If we go to the next slide, I think this is my last slide, just to mention that what could be the policies that has been addressed up to now, and what is kind of required to make it better for the electrification of heat in the European continent. And there are some policies, maybe you have heard about industrial heat electrification auction. This is the funding for electrified heat technologies. And this is a kind of support mechanism for the heat pumps and electrified furnaces, electric furnaces, arc furnaces. And this is an ongoing activity. And in the last year also, we have been hearing about the Clean Industrial Deal, which is the industrial decarbonization focus, and also giving the pathways for low and medium temperature heat activities. And there is the third one is the Electrification Action Plan. This is a kind of coming, not is just really released and published yet, but it is very soon it will be clear. This is a kind of grid integration, flexibility, and lower electricity barriers. This is the purpose of this policy. And the previous one, which is the next one is at the national level, is recovery and resilience plans. This is on the country level funding for electrified heat processes. It's an important electrification investment in an industry, a kind of policy or lever that EU is using. And the last one is the ETS, which is impacting carbon pricing. That helps to make the fossil fuels a little bit more expensive and also funds electrical alternatives. This is the landscape that we are seeing in the EU, how the Commission and the Parliament is supporting the electrification in the industrial heats. Whether it is enough or not, we can discuss further in our panel discussions at a later time. Thanks so much.